the last one, most of you in the chat didn't look at that, but the very last problem, it says, given this is what I wrote, a one step. Is it actually G plus J goes to GJ? In the chat, yes or no? Given this is our rate law, is this a one-step reaction? Yes or no? Put it in the chat. Emphatically no. Thank you, Alba. Or is that just because you're cold and your teeth are chattering?
Accidentally hit it twice.
No. He's a little chilly here. It's cool. All right. So no, it can't be, because this would be G to the first, J to the first if this were a one step. Okay. Good. Now next piece. In this one, pick anyone. If we want to solve for the final answer, we just pick anyone and just plug it in. All right. I'm not going to do the math because you guys can do the math, but I do want you to look at the units. They're going to get a little weird. In this one, the rate is given to us in molarity per second. K is K. G is given to us as molarity. J is given us to us as molarity to the 1/2. So if we solve for K, that's going to be molarity per second over molarity and molarity to the 1/2. So this thing would have a unit of 1 over seconds molarity to the 1/2. Makes no sense. All it is a conversion to get a rate to equal concentrations. It's simply a conversion factor. Weird. Okay. Any questions, problems, concerns on the warm-up? Everybody good? Right. If anybody's not good, give me something in the chat. Or you can vocalize if you like. All right, so back on to what I'm sharing. Let's look. Okay, so the rest of the period is going to be this. The rest of the period is going to be this electronic rate law lab. All right? There are a couple of very important things that I noted there. Hopefully you read it over last night like I asked. You're going to get divided into small group. You're going to go through and you're going to do as many trials as you need to test all the chemicals that can vary.
So for the table, though, shouldn't we include what we're putting for these values as well? Or does that not really matter for this?
Oh, Mr. Ripkins here, so we can ask him.
Oh, sure.
No, I want to hear what you say first.
Hello. No, so I was asking, so for the solution A, solution B stuff where we can change the variables, should we include that in our table?
Okay, well, let's think about this. It's based on the initial. So when you're doing any of the differential rate laws, it's based on the initial. All right. Now,
Okay.
if you look at the column on the left, that's the concentrations of the solutions you're using. If you look at the column on the right,
It's the initial.
it's the initial.
All right, gotcha.
That help?
Yeah.
Mm-hmm.
All right, cool.
Okay, so we do only have to have those the stuff that's on the left, the right column that is changing, and then the rate. All right, so we should probably. Do you guys just want to run the first test with without messing with anything right now?
I'm just trying to set up the table.
Okay, gotcha.
I just don't know how many columns we should have, because I know we should have 4 rows because we need 1 row for the title. I mean, 1 row for the header row, and then we need 3 rows for each trial.
Mm-hmm.
I'm just trying to figure out how many columns we would need. It's like we need. I mean, we
Okay.
could do 1 for each reactant, but I'm not sure if we need arsenious as a column, since we're keeping that constant. But I guess we should just have it there in case. I'll make it a 4x4.
Okay. So what's progress with this group?
Mr. Urban, I have a question.
Sure, Savannah. What's up?
What is it we're supposed to change? Like,
Okay.
Or like what order are we supposed to like change them?
All right. Let's have a look. Let me throw mine up here. Sorry. Okay. Can you see that? You guys able to see it?
You're muted.
Yeah.
Well, let's try that again. Are you are you guys able to see this now? Okay, thanks for letting me know. All right, now here's the deal. This is just like this that we did in the warm-up. Okay? This is a set of concentrations for what? 4 variables. Now this one doesn't, the arsenate doesn't matter because we're not going to change it, so I don't want it in the rate law. But what we're going to do is we're going to do one with this setup. Okay? Just mix the solutions and time it and get the data. So then you'll have a row on your chart that'll have concentration of iodate, concentration of H, concentration of I, and the time it took. Okay? Now the next piece then is we come over here and let's change this one. Now we run it again. Alright, all I changed was this one. By changing this from here to here, I just changed that one. Okay? Now I can change it again, and so I could change this as many times as I like. But if I do that, now this stays the same, this stays the same, this changes, and so my time changes. So I'm going to get a set of data where the first row will look like 0.005, whatever, how many freaking zeros? Okay, there was 0.0002 for hydrogen, for iodate, right? And then another one for iodine, which is whatever it is, 0.05. Okay? And I'll get a time for that. Then I'll run it again where I just changed it, and this will be 0.01. This will be 0.002, this will be 0.05, and I'll get another time. Now, can we do like we did in the warm-up with these two, and the times, or change them to rates, and make it work? See what I'm saying? Does that help?
Does it matter how we change them? Like, are we able to change them like however?
You can change them however you want, but I want you to think, what's the best way to change so that you can see what one chemical does to the rate? Okay, so think about that. Discuss it. I mean,
So how many trials are we supposed to do? Just 3? Or
well, what's the absolute minimum you can do where you have one thing changing at a time? So you're only changing one thing. Think about it. Run it until you've got enough pieces of data where it's like this simple-minded one I just drew up, where H isn't changing, but Q is. Q isn't changing, but H is. So that I can figure out each of these 3 independently. All right? That make sense?
Yes.
Okay, if it tangles you up, give me a shout.
Great God. pH really does something.
It would decrease the pH to like 4.4. Increase it a second. Yikes.
Yeah, that did something.
Mm-hmm.
And then the rate should be 0.66.
Yeah, the rate should be 0.66.
But we didn't really change anything except for the pH though. So should we add the pH onto another?
Well, we still, so the pH wouldn't factor into the initial constant. The only thing that happened that time, it seems, was our
increase
plus H plus doubled.
H plus doubled. Okay.
Yes.
So, guys, what does pH,
yeah?
what does pH represent?
Potential of hydrogen.
Yeah, It's about the hydrogen.
Yeah.
Okay, just checking in.